Well, good afternoon, good evening, or good morning, depending where you're joining us from. Welcome back here to the launch pad, and thank you for joining us for our live launch coverage of NASA and NOAA's GOEST or GOES-T satellite launching today from Cape Canaveral Space Force Station in Florida. If it's your first time here, welcome. My name's Zach. I'm the host here at TLP, and here at the launch pad, it's our mission to inform and inspire the explorers of tomorrow because we believe that space is better together, and we're glad that you're joining us here. As always, we want to hear where you guys are tuning in from. Let us know in the chat, and we'll give some shout outs there. If it's your first time here, let us know that as well. We're going to run through everything we know really quickly about today's mission, and then NASA is expected to begin their live commentary here, and we'll patch them in to hear an update on how fueling and everything is going on today's rocket. We have been keeping track of ULA's site, and here we go. NASA starting a little bit early, so let's listen in.
Coverage of NOAA's GOES-T mission.
So they're getting started. This is the third one that they are launching. It's actually going to be replacing GOES-17 that's had some issues. I'm sure they'll run through all of that, but they are currently moving towards a liftoff time of 4:38 p.m. Eastern Standard Time. Weather has been 70% go. They're just watching the winds. Today's mission is being launched by United Launch Alliance ULA for NASA and the National Oceanic and Atmospheric Administration, or NOAA. They're launching from Slick 41 at Cape Canaveral Space Force Station, weighs 11,400 pounds or just under 5,200 kilograms, and is going into a geostationary transfer orbit.
It's about 40 minutes. This United Launch Alliance Atlas V rocket will launch GOES-T into space. The satellite will continue nearly 50 years of protecting people and property from severe and potentially deadly storms. Welcome and thank you for joining us here at Kennedy Space Center in Florida. I'm NASA's Megan Cruz. The rocket's right there on the pad behind me, and this is Kevin Fryer. He's with NOAA, the National Oceanic and Atmospheric Administration. Great to have you here, Kevin.
Great to be here, and thank you for having me.
It's kind of cold, though. A little windy.
A little windy, absolutely.
I think that's going to be the biggest concern for the launch today, but so far we are 80% go, so I hope that we can see this thing launch today.
Yep, that's great news.
Kevin is here because GOES-T is a NOAA mission. NASA and NOAA have been launching GOES satellites since 1975, right?
Yeah, it's an amazing relationship that we've been able to have with NASA. Over the past 50 years, the one thing that we can say is that we've actually saved lives as a result of that. We've also obviously moved the science forward with advanced satellites, but for the most part, what we like to hang our hat on is that we've saved lives.
Yeah, GOES-T is the third in a series called GOES-R. You know, you're the chief of staff of that program. Can you tell us a little bit about that series?
Sure. Within the program, we like to say that not only can we provide you with a big picture, but we can also read the fine print. Again, being one of the most sophisticated satellites in the geostationary orbit, our capabilities are basically to provide you with a constant view of the Earth. In our case, we're able to look at half of the globe, and in doing so, we're also able to inform you on the environmental changes over time.
So GOES-T is going to be looking at what happens here on Earth in terms of terrestrial weather, but also space weather?
Right. That's another reason why we're incredibly excited about this package that we'll be able to launch today. Not only are we improving what we can see on Earth, but also what affects us from space.
And space weather does really affect us. I learned that while I was researching this mission, so I'm interested to hear more about that, and we will learn more about it later in this broadcast. Plus, how you benefit from GOES data every single day. Also, if you have a flight to catch, GOES satellites play a crucial role in deciding if it's safe to fly. And we also have a fun game for you to play while you watch the broadcast and the launch. This here is a bingo card that you can print out by just scanning this QR code you see on the bottom right-hand corner of your screen. We also have the website there if that's easier. That's scijinx.gov/GOES-T-launch. NOAA has a list of words that we've incorporated into this show, so be sure to listen for those words and see which family member or friend wins. But first, let's meet the talented team of people helping to cover today's launch.
Love that they're trying to get more people to watch for longer.
The launch weather. NASA's Leah Martin will introduce us to key players in the GOES-T mission. And we also have our NASA launch commentators, Daryl Nail and Mick Woltman, inside with the launch team there. You know, Mick is an engineer with NASA's Launch Services Program, which is managing today's launch. So, guys, the 2-hour launch window opens at 4:38 p.m. Eastern Time. How are we looking?
We're looking great so far, Megan, and thank you. Welcome into the Atlas Spaceflight Operations Center here at the Cape Canaveral Space Force Station. Mick Wiltman, as you mentioned, LSP engineer extraordinaire and rocket guru.
Appreciate that, Daryl.
So far, it's good to have you back into the broadcast booth for another launch, and so far, so good.
So far, so good. We just entered the T-4 in holding. This is a 30-minute built-in hold where the team is going to, look at the vehicle and finalize last-minute preparations as we head down to T0 this morning. So the team's done a great job, been on console for several hours, and has gotten this rocket ready to go. So looking forward to this.
That shot from the ground there, looking up at the rocket, you can see the skies are blue. We've got some clearing throughout the day. Started off windy and a little overcast, but there you see the clouds moving across the pad. Very light, very scattered. Now we want to tell you where we are. We are in the nerve center of where launch is happening. We're going to turn around in our seats and wave at the camera. We're up here on this second level, but down below on the first level is the launch team, and you can see the 3 levels there, the 3 rows. This is where all the action is happening.
Yeah, this is the United Launch Alliance team. This is their launch control center, and Daryl, as you said, this back row that's closest to us, this is where the launch conductor, Dylan Rice, is sitting, along with his assistant launch manager, the anomaly chief, Dave McFarland, and our red line monitors, who are monitoring all the telemetry and everything on the vehicle and on the ground. In the middle row, you have the team that is working both the first stage booster and the second stage Centaur propulsion teams there. And in the front row, you have flight control and electrical systems that are monitoring the guidance, nav, avionics, and all the electrical systems on the rocket. So as you can see, a lot of team members from United Launch Alliance to work this Atlas V.
And they've been quite busy for the past few hours, making sure that the fueling operation has gone smoothly. And they were also on console yesterday, Mick, when we rolled this rocket from the vertical integration facility to the pad. We got a little video there, and you can see there it is, the Atlas V coming out, all 200 feet tall rocket coming out of the vertical integration facility and rolling about 1/3 of a mile out to the launch pad. Mick, you were out there. Pretty smooth operation.
Yeah, it was. The team did a great job making that trip about 1,800 feet to the pad, traveling about a half a mile an hour on the mobile launch platform and everything there. And team did great getting that out there and ready for RP1 tanking and then launch today.
You look at the rocket there, and it carries a special dedication today. Mick, it holds the name of a former ULA employee by the name of Mark Tim. Mark started his long aerospace career with the Boeing team in 1987, but after a decade in Denver, Colorado, he transferred to ULA's facility in Decatur, Alabama. That's where Mark Tim supported the ULA's fleet of rockets, including the Delta II, Delta IV, Atlas V, and Vulcan. There you see him in the middle, surrounded by NASA astronauts. Mark Tim passed away in 2020, and he's missed by all those who had the pleasure of working with him during his 30-year career in aerospace. And Mick, you knew him.
Yeah, I got to know Mark when he was in the Decatur facility, and I'll tell you, he was an extraordinary person. The team will miss him, and our heart goes out to the family and everyone that worked with Mark. He was a great guy.
And just wrapping up, we are on time and on schedule for a 4:38 p.m. Eastern Time launch of this Atlas V rocket. A beautiful shot from a drone there. We are ready to roll. We'll have the LSP NASA Launch Manager poll here in just a few minutes, but for now, back to Megan.
Thank you both. And now for a check on the weather, here's Launch Weather Officer Arlena Moses from Cape Canaveral Space Force Station's 45th Weather Squadron. Arlena, this launch weather you're about to report out, forecasted with data from GOES satellites, right?
Yes, that's correct, Megan. In fact, right behind me is a great example of the type of imagery that we get from the GOES satellites. In this case, because we're here in Florida, this is from the GOES East satellite, giving us a great view of what's going on across the Cape and East Central Florida this afternoon. Now, as mentioned earlier, we did have quite a bit of overcast clouds and some low clouds out there earlier today, but as our satellite imagery is showing, we've scattered out pretty nicely with only a few clouds as a concern as we go to the remainder of the launch countdown. The trade-off, however, for those clearer skies and partly sunny conditions is that we do have pretty breezy conditions out there. Sure, anybody who's outside across the Cape this afternoon is experiencing. And those are going to be our primary concerns as we go forth into the count for the remainder into the launch. Now, if we take a look at the forecast here, we're going to be looking at those pretty gusty northerly winds from about 26 to 32 mile per hour range. Temperatures about on point for this time of year here in Central Florida, where temperatures are going to be in the upper 60s to around 70, which will feel a little bit cool if you're outside with that, but for launch concerns, not a big deal. As I mentioned earlier, liftoff winds are going to be our primary concern, with a smaller concern for some of those passing cumulus clouds. But overall, we have an 80% go for weather, and things are looking good. And so hopefully a good launch. Keep our fingers crossed. Back to you guys.
Your fingers. Okay.
There you go.
Arlena, thank you again. Quick check of the clock. We are now at L minus about 28 minutes to go before we launch GOES-T. Now, GOES stands for Geostationary Operational Environmental Satellites. Geostationary refers to where and how the satellite will orbit the Earth. So this might be a little difficult to understand unless you see it, right? So this is why we brought some props here today. Kevin, let's start off by just talking about how you determine a satellite's orbit.
So it's really determined by its overall role, right? What is the job of that particular satellite? So in the case of polar orbiters, they typically will rotate along the poles, and their job is basically to image the entire planet as the planet rotates underneath it. So there is a time frame for which they can provide you a global image. And so again, in a low Earth orbit, that is why you'll see those particular satellites used.
But the geostationary orbit, it has to be in a fixed place, so in the sky at all times, right?
Correct. And actually, to achieve that, you have to be 22,000 miles above the planet, and as a result, so it can actually spin with the Earth as it continues to rotate. So relative to your position on Earth, you will always see this particular satellite in its place.
So that's why we say it will keep continuous watch over the Western Hemisphere with a second GOES satellite, right?
Absolutely. So between the two of them, they'll be able to cover this portion of the hemisphere we're talking about, from Western Africa all the way to New Zealand.
All right, and GOES-T will reach that geostationary orbit on March 12th. And now let's take a closer look at the satellite. GOES-T is the size of a small school bus and weighs over 6,000 pounds. It has a 5-panel solar array, which you see there. It's the one that's kind of swinging out. They'll produce more than 5,000 watts of energy, which is the same amount needed to power your home's central AC system. GOES-T has 6 advanced instruments that can analyze weather hazards and environmental conditions. The plan is for GOES-T to replace one of 2 GOES satellites already in orbit that together protect more than 1 billion people in the Western Hemisphere.
3, 2, 1. NOAA is about to launch a new satellite into orbit above the Earth. This satellite will be the 3rd in a fleet of NOAA's latest generation of geostationary operational environmental satellites, called GOES, the most advanced weather observing and environmental monitoring system in the Western Hemisphere. GOES satellites orbit 22,236 miles above the Earth's equator at speeds equal to Earth's rotation. This allows for continuous coverage of weather systems as they move throughout the atmosphere. The GOES satellite system keeps watch over more than half the globe, from the west coast of Africa to New Zealand, and from the Arctic Circle to the Antarctic Circle. Each satellite in the series provides high-resolution imagery in near real time to provide critical information for weather forecasts, severe weather prediction, lightning detection, and solar activity. The latest satellite is GOES-T, which will be renamed to GOES-18 when it reaches orbit. GOES-T will be the 3rd satellite in the series and is expected to replace the current GOES-17 satellite in the GOES-West orbit. In this position, the satellite will continue GOES-West's legacy of keeping watch over the Pacific Ocean, the western U.S., and the U.S. territories. It will provide complete satellite coverage for the weather systems that impact Hawaii and Alaska. It will provide critical data over the northeastern Pacific, where many of the weather systems affecting the continental U.S. originate. It will monitor and track tropical storms and hurricanes in the Pacific Ocean. It will help identify and track wildfires across the western U.S. It will assist in search and rescue efforts around the U.S. and its surrounding waters as part of NOAA's SARSAT system. And it will help monitor and track weather phenomena that impact the western U.S., like dust storms, monsoons, marine fog, atmospheric rivers, and more. The GO series of satellites supports NOAA's mission to provide secure and timely access to global environmental data and information from satellites and other sources to promote and protect the nation's security, environment, economy, and quality of life.
And if you're just joining us, welcome here to the launch pad. You're joining us for our live launch coverage of GOES-T, set to launch from Cape Canaveral Space Force Station in about 23.5 minutes from now. So far, we've been seeing that weather is now sitting at about 80% go for launch. We love answering your guys' questions, so you can send those in the chat. Just tag us at the launch pad, and we will be answering those live as we continue through the count. We've also now patched in the ULA stream where you can see their live updates coming from their mission control here. So we saw just a few minutes ago their visibility map on where you will be able to see this rocket. It is launching pretty much almost straight to the east, but if you are out on the east coast of Florida, or really most of Florida, you will be able to see this rocket launch for at least the first couple minutes of flight, and then it'll reach up the eastern seaboard just a little bit for today, and you can see it's visible for some part of the U.S. up until about 8-9 minutes after flight. So if you want to see that, head over to ULA.com. You can see that map there, or on their Twitter. But a little bit about today's mission, as they've been talking about how they use the satellites. This satellite is actually going to be replacing GOES-17, was launched a few years ago, that has been having some issues with its imagery. It's been having some anomalies with it. It's still functional. They are still get data from it. In fact, we've actually looked at data from these GOES satellites in our Discord, so if you haven't joined that yet, you can consider joining that. One of the people in the community has been pulling images from those. It's always great to see what we can get from these satellites as they launch. But GOES-T will be replacing GOES-17, and then GOES-17 will be put into a backup mode, and that will be there. That it'll still provide data, but it's not going to be a primary unit, and it's going to just stay up there. Once you've spent that money to build it and launch it, they're not going to just get rid of it, because it is still partially functional, but they want to make sure that they have the best possible data, as they've said, for how impactful this data is. It affects rocket launches, flights, your local weather stations. Everyone uses the data from GOES, and you can see there a live view of the rocket out on the pad as they get ready. Biggest thing they're watching is the wind conditions, sitting at 80% go for launch, and we'll have to wait to see a little bit closer to that. Obviously, this is an Atlas 5. This is a variant 541 that they're launching here today, and it is not a reusable craft, so it will be crashing into the Atlantic Ocean, that first stage in the booster. Once it has deployed and continues on its launch. This is the 8th flight of the Atlas 5 541 configuration, ULA's second launch of 2022, and their 149th mission in the ULA history, so excited to see that. And we are at the 22nd orbital launch attempt of 2022 already, as we ring in another month and begin really a month of launches in March. We've got multiple crew missions, one planned from Russia and one planned from the United States with Axiom 1. We've got multiple Starlinks planned, multiple other satellites, so we'll be bringing those, of course, all to you as we continue through this month. So make sure you've engaged that like and that subscribe button. It really does help us out. Coming down T-minus 20 minutes, 20 seconds, and counting. We're going to listen back into NASA as they give us more updates on what GOES kind of works on, but we're here to answer your questions, so you can send those in the chat, and we'll be answering them as we continue through launch, and we'll be keeping a close eye on any new updates. We just got one here. Vehicle System Engineer is polling the Denver technical team comprised of specialists in various hardware and technology disciplines on the Atlas V. The experts have conducted evaluation of the rocket data and system performance throughout the countdown. The results of this poll will be routed to the ULA Director of Engineering, who will then supply his readiness to launch when the ULA launch director is polled. So they are continuing towards that one of those final go, no go polls. They are still currently holding at T-minus 4 minutes and holding, but this is normal. This is a 30-minute hold that ULA has always built into their launches, and they will have a final go, no go, and then they will leave that poll, and once they've done that, release the count from 4 minutes. Weather update, upper level winds have been verified acceptable for launch at 4:38 p.m. So weather is sounding like it is getting even better, which is great to hear. T-minus 19 minutes and counting. Keep sending in your questions and share out the broadcast. Let people know that we're approaching T0. Stay with us.
Predict, forecast better, and save lives.
When we say much quicker, what does it mean? How often were we getting images in 2010 versus now?
In 2010, we were getting images every 15, 30 minutes. If you think your internet's slow now, it's like hitting the refresh button, right? Now we're getting them as quick as 30 to 60 seconds.
Wow.
And
Incredible.
so that is really making a huge difference for any operational forecaster.
Chrissy, thank you so much for joining us and giving us that insight, because that is really something to think about. Minutes versus seconds, and seconds really matter in severe weather events.
Absolutely.
Thank you, Chrissy. Now, GOES-T also has the latest technology in detecting and tracking wildfires. A few years ago, one wildfire tore through California at an estimated rate of 100 football fields a minute.
The 2020 Western U.S. wildfire season was historic, both for the record 59,000 wildfires that formed and the 10.1 million acres they scorched. But right on its heels was 2021, in which nearly 52,300 fires were recorded, with more than 7.8 million acres burned through December 24th of that year. Since launching in 2016, NOAA's most advanced geostationary satellites are improving fire weather forecasts, wildfire detection, and fire hazard tracking in near real time. With lives and property at stake, timely, high-quality data is critical for firefighting efforts on the ground. NOAA's GOES-17, operating in the GOES West orbit, has shown its mettle detecting and monitoring wildfires and the hazardous smoke they emit.
There's two instruments on the GOES series of satellites which are helpful for wildfire detection and monitoring. The first is the Advanced Baseline Imager, or the ABI. We're able to detect hotspots from the thermal signatures from the fires, and we're also able to detect the smoke and track the smoke with time in order to issue notifications and warnings to the public. The second instrument is called the Geostationary Lightning Mapper, or the GLM. The GLM is important because oftentimes lightning is the cause of the start of wildfires. And so forecasters can monitor the GLM to see where lightning has occurred to decide whether or not they think some lightning may have started a fire.
But a new satellite called GOES-T is poised to replace GOES-17 in the GOES West position. Once it reaches orbit, GOES-T will be renamed GOES-18, and it will provide the same sophisticated technology to track wildfires in the western U.S., as well as detect lightning that can ignite a wildfire in parched vegetation.
This current capability of GOES is the fact that we can do rapid scans, higher resolution with higher sensitivity, and include things for the first time like Lightning Mapper and the ABI instruments. I don't think we could imagine not having GOES capability. We absolutely need it.
The National Interagency Fire Center is the nation's support center for wildland firefighting.
GOES is an eye in the sky. It's giving us a hemispheric perspective with those 16 and 17 without having those two satellites up there constantly staring, constantly monitoring, constantly providing us with information. We really have just a big gap. We would lose a lot of our capability to understand the environment, to see the interaction of the fires with the atmosphere and see how the atmosphere is impacting the behavior of the fires. With those being able to look at the United States every 5 to 10 minutes, we're getting a much more real-time appreciation for how fires are behaving because of the ability of the GOES satellites to detect the heat from the fires.
Kevin, we were talking earlier, and you told me that oftentimes GOES satellites, even at 22,000 miles above the Earth's surface, they can sometimes detect fires before people on the ground even know that they're there.
Absolutely.
That's so impressive.
It's an amazing capability, absolutely. And we heard from our National Weather Service rep, I mean, right there, that's a great example of how it happens. National Weather Service meteorologists are able to view an area, that's not populated, but they can see a heat signature and actually detect that fire. And we found out to the tune of 80% of the time, they're the first ones to actually call and let fire responders know that there's a fire that has just started or is ongoing.
So we know GOES satellites can help National Weather Service, fire officials, as we've said, but I didn't know this, that we use GOES satellite data every day.
Every single day. Anytime you open up your phone and you want to see the forecast and you're opening up an app, a weather app, that's exactly what you're doing. You're actually using GOES information. That GOES data is going directly into the models that inform you on what the conditions are going to be.
Fascinating. I can't. I had no idea. Here I am just looking, and you never think about where it came from. So thank you so much for telling us about that. We're now L- about 14 minutes away from launching GOES-T. Daryl and Mick, it's about time for that launch manager poll you talked about.
It sure is. And before we get to that poll, which is happening at L-13, so just about 50 seconds from now, we got an update from the launch weather officer. You can see on the bottom of your screen the weather briefing there, right there. They talked about the winds. They're still pretty up, but the clouds have dissipated, so we are now at 90% go for launch, improving from that 80% earlier that you heard reported. But Mick, still got a 10% because we are watching those winds.
Yeah, as you can see in the forecast there, where Megan and Kevin are, the winds are still here on the ground, blowing pretty good. The team is continuing to monitor those, but yeah, I'm glad to hear that 90% go.
Winds for upper level, and they will remain green through 2218 Zulu, so significantly into the window. And then we could get a later update should we need it.
Listening to
looks like we have very improved ground winds additionally, so we look great for weather. We've had a really good ground propellant load today, and very, very little activity on the range instrumentation. So with that, I would like to now conduct the GOES-T launch poll. NASA CE.
NASA CE is go.
Copy NASA CE, SMA.
SMA is go.
Copy SMA. SMD.
SMD is go.
Copy SMD. NASA MEM.
NASA MEM is go.
Copy NASA MEM. And LSP.
LSP is go.
Copy LSP. NLM copies. The NASA launch team is ready for the launch of GOES-T spacecraft.
And that was NASA launch manager Tim Dunn that you saw at the bottom of the screen there towards the weather briefing milestone. And so now we're good to go.
Yeah, Chuck, that was a very important. Sorry, Daryl. I'm thinking of that because
you heard
NASA.
Chuck.
I did hear Chuck.
Yeah.
NASA LSP. What I was going to say there is Tim paused at the end there because Chuck Duvall, NASA LSP, this will be his last mission as he just announced his retirement from NASA after 40 years. So this mission, Chuck, GOES-T. Thanks for everything you've done, and thanks for that go.
Been here a long time. Didn't he start as an intern?
He did.
Yeah.
He did.
That's a long career. Well, congratulations to him. And here we are with the rocket on the pad, ready to go. We're going to pick up this countdown. We're also going to have a special message from somebody you may know, a very popular and somewhat famous meteorologist. We're going to get to that in a second, but we'll send it back to Megan for now.
And we're going to take a moment, answer a few of your questions. We're also going to patch in a live view down from by Cape Canaveral, taking a look at the live weather conditions down there and waiting for liftoff here in about 11 minutes from now. Weather's currently green on the pad as they prepare for launch here today. If you guys have questions, send those in the chat. Just tag us at the launch pad, and we will be answering those live as we continue towards liftoff here. We are also still monitoring the ULA website as they updates, but everything is showing that they are ready for liftoff here today. The GOES-T satellite is going to operate at about 36,000 kilometers or 22,300 miles, and is going to cover the western half of the continent, including Alaska, Hawaii, Mexico, Central America, and the Pacific waters, and will be renamed GOES-18 once it is actually in location. Are those launch days that we pass can be such an event to all the... Not sure what you're meaning there, astronomer. Can you let me know? Sorry about that. You're in the PNW. Looks clear. That's awesome, Mark. Good to hear. It's awesome hearing how those will how this data works for you. Hey Carlos, good to see you. Inspire 24, awesome. We're coming down T-minus 9 minutes, 30 seconds and counting. But the launch conductor, Dylan Rice, is remaining all console operators that has been informed all console operators that if a constraint is observed at the L-minus 7 minute readiness poll, the team member shall now announce hold across the communication loops and their reason for the hold. So right now we are currently in a T-minus 4 minute hold. So there's actually 2 countdowns operating right now. T-minus and L-minus. T-minus is countdown to liftoff in the countdown time frame. L-minus is actual real-time minutes. So you could be T-minus 4 minutes, but right now we're at, which is what we are, but we're actually at L-minus 8 minutes 40 seconds. And that has to do with being the 2 different counts because of the built-in holds. We're standing by for that readiness poll, so we're going to listen into that, and that will be what is a go, no-go to continue the count at T-minus 4 minutes till launch. But so far, everything is seeming to be ready to go. So we're going to listen back into NASA Mission Control and the ULA to hear an update as we await for that polling to begin.
Thank you so much for joining us today. We're looking forward to this launch. I'm sure that you are as well, and we really appreciate you being here.
Thanks so much, Leah. Absolutely.
Megan, we'll send it back to you.
Thank you both. And now taking us the rest of the way of the launch countdown is Daryl and Mick. Guys, take it away.
All right, thank you, Megan. L-minus 7 minutes and 50 seconds until liftoff. Welcome back inside the Atlas Spaceflight Operations Center, the launch team right behind us, working this launch. And so far, things have looked really good and sounded good over the nets.
Yeah, everything sounded great. The team is continuing to finalize their work as we get ready to pick up the count at T-minus 4 and sync up the L clock and the T clock. We're coming up on that launch conductor poll at L-minus 7 minutes with Dylan Rice, so I'm looking forward to hearing all goes from.
There's actually a really great view of the different countdowns that they have, time of their launch window, their L-minus, their T-minus, and everything there, and that is inside the mission control.
Polling, which is at L-minus 7 minutes. In just a few seconds, we're going to pull up the poll on the right side of the screen and count it down.
7 minutes. Status check to proceed with terminal count, Atlas Systems, propulsion.
Go.
Hydraulics.
Go.
Pneumatics.
Go.
LO2.
Go.
Water.
Go.
Centaur Systems, propulsion.
Go.
Pneumatics.
Go.
LO2.
Go.
LH2.
Go.
ASGAS.
Go.
Electrical Systems, airborne.
Go.
Ground.
Go.
Facility.
Go.
RFFTS.
Go.
Flight control.
Go.
GCQ.
Go.
Operation support.
Go.
COM.
Go.
Umbilicals.
Go.
ECS.
Go.
Redline monitor.
Go.
Quality.
Go.
Ops safety manager.
Go.
ULA safety officer.
Go.
Vehicle system engineer.
Go.
Anomaly chief.
Go.
Range coordinator.
Clear to proceed.
Launch director.
You have permission to launch.
Proceeding with the count. ALC, verify T0 is set for 21:38 Zulu.
Verified.
ULA launch conductor Dylan Rice getting green across the board.
Yeah, that was great to see Dylan choreograph that poll, the culmination of several hours of work by this launch team, and then hearing Launch Director Tom Heater from United Launch Alliance giving that ready to proceed for launch today. So very excited and happy here to hear that as we get ready to pick up the count.
As we look outside at the rocket, we can see those blue skies. The clouds are moving a little bit, very, very slight amount of clouds. You don't see it here, but we're looking at blue skies. You can see some of them there. They're moving. That's representative of those winds. But as we know here in Florida, it's such a beautiful time of year in March. But Mick, 3 months from now, it'll be the start of hurricane season, which is a concern for Florida and everyone along the Atlantic seaboard and in the Gulf states.
Yeah, and I'll be.
And as we heard there, they are currently go for launch. Everything ticking along well at L minus 5 minutes. They are going to resume that count in 1 minute from now and pick up the T minus count as things progress towards. But you heard there through the polling, everything is clicking go for launch. They are ready to go, and they have permission now to officially launch. They are entering that final count. We got this live view above me here. Keep in mind, we're going to see liftoff here most likely up to 30 to 40 seconds prior to the actual liftoff sequence, but we always try to bring you guys live views from down at the Cape as we can, and so grateful for Ty being down there on location. Coming down, T minus 4 minutes, 30 seconds and counting. Take a moment, engage that like button. It really does help us out, and glad to have you all here. Virginia's got a question. Do you know how many ghost sats do they still have up there? They talk about 2 specifically for the United States, Ghost 16 and Ghost 17, but they will be working on replacing Ghost 17 with a Ghost 16. Again, looking at that count, you can see there, L minus and T minus are both now ticking along as we have exited that hold, and we are now T minus 3 minutes, 50 seconds and counting.
Very thoroughly.
We're going to keep listening in to mission control here. No lag, just time delays, and that's how the internet works here. But we are T minus 3 minutes, 30 seconds until liftoff.
Getting the vehicle on internal power, which we heard a little while ago that the spacecraft Ghost T is configured and on internal power, ready for today's launch. So we'll be finalizing all these steps, the United Launch Alliance team that we talked about earlier, and they will get Ghost T ready for a liftoff at 4:38 p.m.
And there you can see from that shot of the pad out over the Atlantic Ocean, you see down towards the bottom of the rocket, those 2 solid rocket motors. There's 2 on this side, 2 on the other. This is an Atlas 541 configuration, which we know is going to provide a lot of performance.
T minus 3 minutes.
New GEM 63s.
Yeah, Daryl, the 541, as Tori Bruno, CEO of ULA, likes to refer to it as the Dominator. Those 4 solids will provide a lot of thrust as we get Ghost T off this morning. Using those new GEM 63s from Northrop Grumman will provide a little extra performance and get Ghost T on her way.
You can hear the team really picking up the chatter here as we get down to the final minutes for the launch of Ghost T on board an Atlas V rocket from right here at the Cape Canaveral Space Force Station.
Yeah, Daryl, we heard the team, they secured the Atlas tanks to flight pressures, secured that topping. So we see that the liquid oxygen on board that first stage is secure and ready to go. We should be hearing them at about 1:50 securing the Centaur tanks and getting that tank up to flight pressures.
T minus 2 minutes.
Spacecraft is on internal, getting ready to listen to the vehicle.
155.
Launch sequencer start.
150.
Securing Centaur LH2.
Securing Centaur LO2.
So there we hear Daryl, vehicles on internal. The auto sequencer has taken over and started the count. And
Launch
Centaur
enabled.
LH2 and LOX
137.
sequences are done. Launch has been enabled by the.
As always, as we pass through that T minus 2 minutes, let's see a go, no go in our chat. If you're a member, you can see and you can use those emojis as we pass T minus 90 seconds. In the next 30 seconds or so, you should see liftoff occur above me, and then we will have the live view from NASA and ULA. So let's listen in as we count down T minus 75 seconds and counting.
110. Vent valves locked.
And there we hear the vent valves locked, securing everything to secure that boil off. We should now be coming up on the last call for the range.
1 minute.
Rock, report range status.
Range green.
And there we have a green range, Daryl. So everything looks good
Great
this
sign
morning.
there. The weather
Last
is
but not
go,
least,
the
we will bring
range is
everything
go.
to flight pressures, and then
T minus 50 seconds. Any moment, we should see it above us here.
An exciting moment indeed as we look across the river there to a shot of the rocket. Just
T minus 40 seconds.
Stable at step 3.
And there we verified that all pressures are good, and we are stable at step 3, ready for liftoff this morning.
T minus 30 seconds.
Verify ECS reduced for launch.
Verified.
25.
Status check.
Go Atlas.
Go Centaur. Go Goes T.
And there she goes. As you can see on your screen here, we do have liftoff from Cape Canaveral Space Force Station.
The final seconds now. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And liftoff. Liftoff of NOAA's GOES-T, our newest weather sentinel in the sky to help keep us safe here on the ground.
Daryl, let's listen in as we listen to United Launch Alliance Wildfire.
Those look good.
Who's the flight mission commentator?
View has gone to closed loop control. The RD-180 is now throttling down as expected. Engine response looks good. We are now 33 seconds into flight. Atlas is 3 miles in altitude, 0.9 miles downrange distance.
Execute 48 seconds.
An incredible view above me thanks to Ty being down there at Cape Canaveral of the launch. You see the arching.
Throttle back those RD-180s.
Now 55 seconds into flight. Atlas is 7 miles in altitude, 4 miles downrange distance, traveling at 1,900 miles per hour. RD-180 is now throttling back up.
We backed off the throttle to
Now
reduce
at
the stress
75
of the
seconds
rocket.
into flight, Atlas is 13 miles in altitude, 10 miles downrange distance, traveling at 2,700 miles per hour.
Can still just make out that rocket, leaving little contrail there.
Now at 90 seconds into flight, ULA's Atlas V rocket weighs now just 1/2 of what it did at launch, burning propellant at a rate of more than 2,600 pounds per second.
Couple
In 10
Pelicans
seconds,
coming to
those
visit.
Solid rocket motors on the side will cut off.
Stand by for SRB jettison.
Beautiful shot from space.
Absolutely
SRBs have
fantastic
burned out
view,
as
and there's the
expected.
SRB jettison.
And we see a good SRB jettison.
Clear shot of those
Vehicle is now
SRBs.
executing closed loop steering.
Here in a few seconds, they're going to throttle back up.
Vehicle performance looks good at this time. Now 135 seconds into flight. The RD-180 has throttled down slightly.
Currently burning propellant at a rate of 1,700 pounds
Tank
per
pressures are
second.
stable, and Atlas booster battery voltages remain in their expected ranges.
Atlas now weighs a quarter of what it did at liftoff, coming up to 3 minutes into flight.
Now the upper stage is preparing for its use. Centaur reaction control system is now pressurizing to flight levels.
So that's them saying that they're prepping the second stage for that separation.
Now they'll jettison the payload fairing, which protects GOES-T at 3 minutes and 30 seconds.
About 30 seconds away from fairing separation.
We have just over 1 minute until BECO. We're now seeing the RD-180 throttle limiting to maintain a 2.5 G acceleration limit. Standing by for payload fairing jettison.
And there goes that fairing.
Successful payload fairing jettison.
Good shot of those fairings.
Those flakes you see peeling off, those are ice. That's because of the cryogenic fuel, so that's normal to see. GOES is geo-orbital something stationary. It's actually in the thumbnail of the video. Don't have that right off the top of my head. Let me grab it.
And you're looking at animation now.
We've seen that the Centaur has begun its boost phase tail down sequence.
We're about 30 seconds away from MECO and Atlas Centaur separation.
Booster about to cut off.
And BECO, booster engine cutoff.
And there's
standing by for stage separation and a successful stage separation event. We've seen pre-start on the RL-10. And mess one, we have ignition for the first burn. This first
There's
burn of
second
ULA's
stage
Centaur
ignition.
upper stage will place the GOES-T spacecraft into a parking orbit around the Earth. This burn will last just over 7 minutes.
What a shot there, huh, Mick?
Yeah, that was great, Daryl, to see all that and listen to Rob Kesselman call that flight. The first stage performed very well this afternoon, and everything's looking good. Those gyms.
Reaction control system as it begins its periodic firings to maintain thermal control conditioning.
Yeah, those GEM 63s performed well, solid rocket boosters, and RD 180 performed as well. What I really liked was when we saw the payload fairing come off. That was a great shot from the camera. Saw the payload fairing come off, and then most people probably noticed that little half cylindrical come off after payload fairings. Yeah. That was what we call the Centaur forward load reaction deck. Because the fairing, the 5-meter fairing, encompasses both Centaur
as expected
and the GOES-T satellite, there's a load ring that's inside the fairing around Centaur to help keep that 5-meter fairing from flexing. So that's what you saw when you came off there.
I was wondering about
and
that.
the engine response remains nominal.
And so
word from the trajectory and performance group that booster performance was as expected for the booster phase of flight.
All right, we're going to keep an eye on this burn and listen in. But in the meantime, we'll send it back to Megan out at the host desk.
If you're just joining us, welcome live to Kennedy Space Center in Florida, where we just saw GOES-T.
If you're joining us live, you're a little late, but that's okay. You guys can spin around, make a Pelican shirt. I'll buy it. Done, Bailey. We will make one today. It'll be up on the shop by tonight sometime, or first thing tomorrow. We will make one. Any ideas what you would want on it? You just want a Pelican with a rocket going off behind it or something? We'll make it. But thank you so much for you guys for joining us. We're going to keep watching here as that first burn continues at T plus 6 minutes, 30 seconds into flight. The first stage performance numbers show a good burn of that first stage, and now that Centaur engine is performing well. The Atlas V remains on course, flying across the Atlantic Ocean. It has just under 5 minutes left in its first burn, which is going to put it in a good parking orbit, and then they will use 2 more burns to actually position the satellite in its actual spot. Popcorn, yes, correct, it's GOES-T, and then it will be renamed to GOES-18 once it's in position and operational and join its partners, GOES-16, and it will be a replacement of GOES-17. If you guys haven't yet taken a look at it, head on over to our shop. You can use promo code LAUNCHDAY, get 10% off of everything in the shop, as well as you can head on over to our Discord. We're going to be hanging out in live comms following this mission, and we hang out in there pretty much every night. Again, I want to say a big thank you to Ty being down there on location for us, giving us that live view with the Pelican. It was a great shot and great tracking as usual, so we appreciate you being down there and you guys for being here. If you guys have questions, let us know in the chat. We can continue answering those as we continue through this launch phase. A little bit, being a NASA mission, we don't normally see a lot more from them, unfortunately, as they are focused on, the guests and different things that they have brought. So we won't have a lot more views from ULA other than of that animation coming up to actual events that will occur, but we are monitoring ULA's live website for updates as they continue, and that's where we're getting confirmation as things continue to progress. Dogtone's asking, what did this rocket cost? A lot. No. Cost of an Atlas V is, they range from 110 to 153 million back in 2016. So I don't believe we've had super new numbers for it, but they are not the cheapest there. Does the view of the camera from the rocket have an auto mode? The one that's on board? Yes, it's something that ULA gets, and then it's up to them deciding. Bailey, Pelicans in front, SRB plume in the back. Like a Pelican with an SRB flying behind it? Or you want just a Pelican in the front and then a rocket launching on the back? Or both? We have options. Bailey, if you're in the Discord, I'll drop some ideas in there a little later today. Kevin, you're correct. GOES-T is the third of the GOES-R series, so there will be a fourth one that will be made and launch in the next couple of years. ULA is the United Launch Alliance, not University of Los Angeles. That's UCLA. Kevin, 145 million. Appreciate it. How is the GOES sat last? How long do they last? They can last, I mean, if they're operational a long time, they can last, let me double check here. You guys asking good questions today. I'm not even sure we have all of these. The GOES R series are expected to last until December 2036. And they are replacing a earlier series that was GOES 13, 14, 15. So that is what they are doing there. As we reach T plus 11 minutes into flight, we have about 1 minute left in that burn of the Centaur engine, which will put the payload into a preliminary parking orbit. We're going to remove you. Thanks for being here. Thanks, Widow, for jumping on that. Antons, what about a pelican sitting on the pointy part of a rocket as it lifts up? That would not be good. That would not be good at all. Absolutely, Dogtones, we want to stay united, absolutely. Yeah, 2036, so we've got about 15 years they are expecting, but they'll stay up there for a while. Oh, the shuttle batch. That was such a sad video, Bailey. But yes. And we are coming up here about 30 seconds away from confirmation of MECO 1, which is the confirmation of the first cutoff of that Centaur engine. So let's listen in to ULA Mission Control.
Monitor the flight of the Centaur and GOES T.
Yeah, things are looking really great on this flight, and coming up on MECO 1 of that Centaur engine as Centaur continues to perform nominally. We've heard pressures and everything look great.
PU system has gone open loop.
Here in about 10 seconds, we'll have the
Standing by for the end of the burn. And we have MECO. Main engine has cut off.
There you go. That completes that first burn. And so now we go into about an 11-minute coast phase.
At this time, the GOES T spacecraft and ULA's Centaur upper stage are in an unpowered coast phase that will last approximately 11 minutes. The coast allows the vehicle to move to optimal orbital position in the orbit prior to beginning the second main engine burn.
And what you're looking at is animation that is tied directly to the telemetry we are receiving from the rocket.
Yeah, the team is using all the vehicle telemetry to look at and power this.
The control system is operating at the 100% settling mode at this time.
Power this animation that we're seeing, which is.
Francis is why doesn't their second stage glow like red like most others? We haven't seen a lot of the camera, so it definitely will glow when it lights when it heats up there. It's also different materials and different things that cause that to occur. So that's one of the reasons. Also, just the lighting in space will affect how it looks. Great question there. No one needs to build the ark. Maybe one day. We'll see what happens, Jay. Let's keep listening into Mission Control. Currently coming up 800 seconds into flight. Currently has an orbit of 171 kilometers for perigee, 491 for apogee at an inclination of 28.1 degrees.
So we can't see the Earth behind it. They give it that kind of accuracy in terms of its look. So the spacecraft is in total darkness, but when it comes out and those solar rays unfurl, it'll have some power. All right, we're going to send it back to Megan for now and while we coast, but we'll be back for that second burn.
Thank you both. Now, GOES T will warn us about weather here on Earth, but also space weather. But what is that, and how does it impact us here on the ground? Take a look.
So I'm going to play a animation video here about what is space weather. It's something that we've heard a lot about lately with Starlink and how they lost that two launch the GOES payload due to space weather. So very interesting to see with that. We are going to be talking a lot more about space weather as we get ready to go back to the moon and then on to Mars, because in low Earth orbit we still have quite a bit of protection thanks to our planet, and it's a lot easier to evacuate home if we needed to. But once you're going to the moon or Mars, you can't just make a U-turn and come home. You have to actually watch that impact, as you can see in that animation right on the screen right now. You can see just that impact of what our Earth really does, and we're getting ready to leave that, and it takes a lot of planning and forecasting, and that's why they are looking at space weather a lot more closely now. Astronomer, I get you too. I'm tired of the spam bots as well, but try to keep on them as much as we can. Let's see. If you guys have questions, you can keep sending those in the chat. We've had confirmation though that MECO 1 was good, and we are in a good preliminary parking orbit, and we will now coast for about 10 minutes before the second burn is set to begin. There are 3 burns in total scheduled, and then we will see payload deployment as well. Fairground, great to see you. Thanks for being here. If you guys haven't done so yet, take a moment and engage that like button. It really does help us out. So you can see where those ghost satellites are going, and they are in kind of that sphere of protection of our Earth. Yeah, Astronomer, that's a good point. It's really weird that YouTube sometimes allows them, but that's okay. We've got our team working on it, and we'll be helpful. Seeing about other questions as they come in. ULA launch is a little bit different as we don't see a lot from them, unfortunately, especially once it's up in orbit. Going to take just a really quick commentary break here, and I will be right back. So stay with us as we count down about 7 more minutes until we see the second burn of that Centaur engine. Stay with us.
All right, take it away, guys.
Hi, Dr. Spinrad. Thank you so much for joining us today for the GOES-T launch. We really appreciate it. So this launch is actually not the only NASA NOAA launch that we have a collaborative effort with this year. We have another one coming up as well.
Yeah, that's right. Thanks for having me. And in fact, this next launch will be a polar orbiter, which is fundamentally different from what we launched here today. So we call it a geostationary satellite. As the name implies, it's Earth synchronous. It actually follows around and looks at one spot on the Earth, if you will. And then the JPSS launch is we call it a sun synchronous. So it actually stays at a certain sun illumination and does orbits around the pole many times to give us a different look at the Earth as it's spinning on its axis. And you take the JPSS satellite data and the geostationary data together, and it's like taking pictures at multiple angles to get a much better idea of what's happening on the planet.
So that's information that we can use independently, but we can also use them together just to get a better picture of what's happening.
Absolutely. Think of it in terms of being able to forecast weather, say, 2 days ahead versus a week ahead. And if you've got multiple views of the planet, you can start getting a much better handle on when hurricanes are forming, where they're forming, how intense they are, or things like atmospheric rivers forming way out in the middle of the Pacific. When will it arrive in the Pacific Northwest? So having these multiple ways of looking at the Earth gives us a lot more and a lot better information for these critical forecasts to save lives, protect property, and basically protect our American public from these natural phenomena.
Now, and the system that is currently on orbit is set, I believe, to go through the 2030s. What comes after this?
So we've called this series the GOES-R, the Geostationary Operational Environmental Satellite R series. There are 4 of them. We've launched the 3 here today. And after this series, we're looking at what we call GeoXO, Extended Observation. So what does the next generation of geostationary satellites look like? What's the newest technology we can put on there? Are there different phenomena that we can look at in the Earth system, but also out at the sun, for example, to understand what's happening with solar storms that impact us here on Earth as well.
So really, it's science for today while we're facing forward to science for tomorrow.
It absolutely is. You think about how many years it takes to build a satellite like the GOES series, and you want to make sure that you're putting the state-of-the-art science and technology in the satellite that may not launch for 5-10 years. So what do we think the scientific capabilities will be in 5 or 10 years? And let's start working in the laboratory now to build those new sensors and those new operating systems.
It's incredible to think that, you know, in just another decade or more that we could be here talking about a completely different system. Thank you so much for joining us today. We really appreciate it. Megan?
Really interesting to hear about everything that's happening that we can really all learn from. It's been about 21 minutes since launch. Dale or Mick, we're coming up on that second burn now.
Yeah, we sure are. And thank you, Megan. Back inside the Atlas Spaceflight Operations Center, Mick Woltman here with us, LSP engineer. We're heading towards orbital sunrise. We've been in a coast phase right now, heading over Africa, West Africa, across the southern coast there. And we've got a burn coming up in just about a minute.
Yeah, this second burn is very important as it'll get us out of this park orbit around Earth and get us on our way towards that geostationary orbit we want to head for GOES-T to allow them to do their science and protect us with all those instruments they've got for weather realization.
You're looking at animation now tied to real-time telemetry. The Centaur on the left part and GOES-T on the right part as it chases the sun. Mick, chasing orbital sunrise here in just a few seconds, and ULA kind of basically simulating that with a more lighted landscape.
And there we hear pre-start on the RL-10 coming up from Rob Kesselman.
We're waiting for that ignition of that second burn to occur here.
LOX pre-start on the RL-10. We have ignition, MES 2.
There's ignition of the Centaur for the second time.
Number 2, we have advanced across the bottom of your screen where we have all the milestones listed. We're going to burn for about 6 minutes. As you mentioned, Mick, this is really hitting the gas
PU
and
has
getting
gone to
out
closed loop
deeper into
control.
space.
Yeah, absolutely. This is going to be the burn where we get GOES-T headed out where it needs to be, and then we'll coast for that 3-hour period
Vehicle body rates are stable
to get where
during
we
this initial
need
part of the
to
burn.
go, and then get ready for separation. So still a lot to go from here, but this is a very important burn for the mission.
Going deeper into space, approximately 22,000 miles away from the surface of the Earth.
Switch our screen here for a second. As you can see, the live telemetry there in the top right corner of the big screen. Perigee at 164. Before it started, it was less than 800 in apogee, and now it's passing, as you can see, very quickly. 17, almost 1,800 kilometers, and increasing for this burn. The inclination currently 27.6 degrees, so it is turning ever so slightly its inclination, but that apogee quickly increasing to get it out to its orbit, its operational orbit.
Of LSP's young engineers to share and install this equipment that helps protect against delays. Let's check it out.
Hey, Alex.
Hey, Daryl.
Good to see you.
Good to see you too.
Hey, thanks for having me out. So this is it.
This is it. This is the PLI.
The NASA Portable Lightning Instrumentation. I see it right here. You're going to take it up there all the way where the top of the rocket is?
Yeah, right around where the payload fairing is, level 5.
All right.
That's where we're going.
Well, you need a hand?
Yeah, come help us.
Now that we're inside the VIF and we're about 13 stories up, Tell me a little bit about this box. You've got some, looks like some sensors here.
That's right. So we got the current probe, which is over near the rocket, and we have 3 more sensors over here. This one is an electric field sensor. This one up here is a magnetic field sensor. And this little one over here, that's a GPS antenna. That's how we get it, make sure our data stays synchronized in time, so that we can correlate that data to all the other lightning detection networks in the area.
So what happens if there's a lightning strike somewhere nearby? What does this do?
So if it's close enough to cause any interference in this area, these field sensors will pick it up first. And they'll cause the entire system to take a snapshot of that data and record it.
And how is that helpful?
We'll know what the peak of it was, we'll know how long the transient lasted, we'll be able to calculate how much energy traveled through there, we'll have a lot more information to work on.
Small box, big rocket, but it's got a big role in the whole scheme of things.
It's got a big job, that's for sure.
So we can see those lightning towers out there.
That's
and ULA
right.
tells me that that protects the rocket when the lightning strikes. So why do we need the PLI?
Yeah, so this system over here, we call that the lightning protection system. That's designed to protect it from a direct lightning strike. That means the lightning is attaching directly to the rocket, and we're concerned about, a lightning strike out there in the ocean, maybe just a mile away. And the energy in a lightning strike is so intense, it creates these very powerful magnetic and electric fields. And those are the things we're concerned about, because that magnetic field can come through and couple into the umbilical cable. It's a huge loop. It makes a big old loop, and that's the current we're looking for with the PLI.
Has the PLI ever prevented a long launch delay for a previous mission?
Mars 2020 was where the data from the PLI gave the spacecraft team the confidence to go ahead and launch.
So there was a lightning strike around the Mars Perseverance rocket.
That's right.
And you saw it?
And we gathered that data, yep.
And it launched on time.
It did. And it's up there now.
That's right, on Mars.
That's right.
Well, that was a lot of fun to go out there, and Alex, of course, was great to have me out there at the pad. But this technology, really helpful when you have a lightning strike. It was connected up inside the VIF when GOES was inside.
Yeah, Alex and the team have done a great job with that. They've been studying this for years, and they came up with this PLI, and working with our commercial partners, they've been able to install it, like you said, on the VIF for the Atlas V mission. And as Alex mentioned, we actually used it during Mars 2020 to help us verify some information, so we didn't have to go back and retest anything, and it actually saved the launch from delaying. So, the hardware is great for what we have involved in it.
Especially important.
And we're going to be coming up here on that engine cutoff occurring in about 20-30 seconds from now is when we're expecting to see that occur here, as it has extended its orbit. Apogee now showing all the way up to 31,000 kilometers and still increasing, and there's that cutoff now holding a perigee of 187 kilometers, apogee 32,600 kilometers, and now holding a stable orbit. And we do have another burn still scheduled to increase that perigee.
A stationary point where they want to get that geostationary orbit.
Yeah, this is the moment we've been talking about a little bit, right? This is that 3-hour coast that we're going to have Centaur and GOES-T do their thing, head out towards that geostationary where they want to get to, so we can have that third burn of the Centaur. And what we'll see on that third burn, Daryl, is that after that 3-hour coast, Centaur will go through its process again of pre-chilling the engine, doing some things to get ready for that.
Centaur is now entering an extended duration coast phase. This coast phase will last approximately 180 minutes.
And with that countdown to that third burn is 3 hours and counting. ULA doesn't have any live view video up for this mission here today. It is all being brought to us by NASA, so it isn't something that we'd be able to unfortunately leave up as we normally would, like we do with Starlink and things like that. So we're going to wrap up our live broadcast for that today. Make sure you follow ULA over on Twitter, as they are giving consistent updates throughout today, as well as you can go to ULA.com/ULAlaunch.com and see a live blog there giving updates on the rocket as it continues on its path to deployment in 3 to 4 hours from now. We got lots of launches coming up later this week that we hope you will join us for. We got a bunch pre-scheduled, more to come. We are still planning to have a Starlink launch on March 3rd in the morning. We've got OneWeb launching on a Soyuz maybe on March 4th. March 8th, we've got a Starlink. March 15th, we got a Starlink. We've got Soyuz on March 18th, and we got Falcon 9 with Axiom 1 on March 30th, and maybe even more. We'll wait and see. So make sure that you have engaged that subscribe button, turn on your notifications, so we will be able to hear that. And we are glad to have you all here. But that's going to wrap us up for today. Here at the Launchpad, it's our mission to inform and inspire the explorers of tomorrow, because we believe that space is better together. And this is Zach from the TLP Studios signing off. We'll see you next time. Bye-bye.